Alright, so geometric series, let's go to the top left. The geometric series, I'll use that one as an example. 1, 3, 9, 27, 81. Okay. So a geometric series, we're not adding anymore. Now we are multiplying. And we'll always multiply, but you can think of the inverse of that as dividing. Sometimes we end up getting smaller. And you will see probably geometric series more in calculus than you will see arithmetic. Speaking of multiplying, what's the pattern with this series? What are we multiplying by? We're multiplying by 3, right? One other thing, I didn't tell my classes yesterday, I should have. With arithmetic, you got a line, right? Look at these numbers. If you were to graph this, what type of function are we going to get? Exponential, you're exactly right. You will either get an exponential growth equation or decay if you are dividing. Okay, and we'll talk about what's going to be what. So this goes back to chapter 3. You will have an exponential equation here. Alright, so what's the formula? Some of the same terms are used, so some of the same common language. S, your sum, equals A1, which represents what now? First term, times R, which is a new letter, I'll tell you what that is in a sec, to the n power minus 1 divided by R minus 1. Now this should make a lot of sense. If you look at this equation, this is an exponent, right? Yeah. That's why we're going to get an exponential graph. A1, you already said was your first term. What does n represent? Your number of terms. And then here's this new letter. What do you think R represents? The number you're multiplying by. And we call this our common, kind of like we had that common difference. Now we call this a common ratio. That's why we use the letter R. Another way we might refer to this is our multiplier. So right below it, go ahead and write an example. And I'm going to give you this sequence or series, and you're going to solve it using that formula. Okay. All right, I'm going to give you guys, let's say, 1. Let's see, Devontae, what's my R? My R factor is 5. It's always helpful to kind of write that out too, that you can see 5 here being multiplied by. Let's see. Moy, what is our N? 7 minus 1 all over 5 minus 1. Okay, please do not type this all on your calculator at once. I just want you to do it in parts. Do 5 to the 7th minus 1 first. And then somebody tell me that number. 7, 1, 4? 2, 4? 1, 2, 4 like this? Okay, now 5 minus 1, do that in your head. 4. Now go ahead and divide all that. Don't type this all on your calculator, you'll make a mistake. And then what's our solution? 19,531. Pretty straightforward. Alright. Go back to your graphing. Alright, so here's our example. And it's from the CPM 7.3.2. Abra is saving $200 a month at 1% annual interest. And then I'm going to add one more thing. Compounded monthly. And then the question we're going to answer is, how much will she save after? Now we're going to look at two different scenarios. Here's the first one. 10 years. So say she's graduated college, she's got a decent paying job, she's working at Da Vinci, she can put $200 in the bank a month, and this is a super low interest rate. It's actually really good right now. About 5 years ago, when the economy was like doing really well, a lot of banks were giving 3 and 4%, so that's like, it was pretty good. Now most banks are giving less than 1%, just because the economy people don't have a lot of confidence in the economy. So how can we figure this out? Well, what's happening is this is actually a summation, and it's a geometric summation. You have a question, or you have some thoughts?
No, yeah, we have to separate it to months.
Yeah, you're gonna separate the months in. We're gonna go from years to months, and we're gonna use our equation again. Sum equals A1 times r to the n minus 1 all over r minus 1. Now, how does this connect? Well, this is actually a summation. So, first, Moise makes a really good point. We're compounding monthly, meaning every time you put $200 in, they take 1% interest at the end of the month on whatever money you have in the bank. So convert 10 years to months. 120 months, okay? So what we're actually doing here is we are actually creating a summation that's going to look something like this. And I want this to make sense to you, so I'm going to actually write it out in expanded form. How much money are you putting in each month? 200. And the interest you're getting on this is what? 1%. So how we're going to multiply this by what? 0.01. But we actually have to multiply it by 1.01. And then we go all the way down. This is your very last month. When you put money in that last month and you take it out, do you get any interest on it? No, that's why you take this to the 0 power. It's just 1. 1 times 200 is just 200. So when you put it in that last month, you're not getting any interest. Okay? Now, do you want to do this all in your calculator? No, you either want to use summation or you can use this. Try to set up an equation using that. $200. You put 200 in. All right. What's next? What's my R? It's my rate, 1.01. How many terms do I have, or how many months is it in there for? 120 minus 1, right? Over 1.01 minus 1. All right, go ahead and figure this guy out. Make sure you're using parentheses. Much to you. So there's our answer, $46,774. If you put $200, takes 200 and multiply it by 120 with no interest. What do you get? What was that? 24,000? 24,000, right? All right, so without interest, if you did not get 1% interest, which is tiny, you would have 24,000 after 10 years. With 1% interest, we're almost doubling our money. So you can imagine, you're getting 3 or 4% interest. That's a really good rate of return. Okay, you will have